go. Hello, everybody. I'm here again. So I promised that we're going to make a video of t-test. Oh, this is very thin. Of t-test method on how to um, test your hypothesis if you're going to accept it or not using t-test. Now, there are two for this t-test. You will just be comparing two groups. As you can see here, I've got my mean sample A and the mean of sample B, and you have the standard deviation of the sample A and the population or the number of samples you have in A group, and then you have standard deviation of B group and the number of samples in B group. So all you need to do, as you can see from the formula, you have to square the standard deviation of A and divide it by its number of samples. Same is true with B and its samples, and then you add them together, get the square root. That's for the denominator. And then in the numerator is just taking the difference of the two means. And then you get the T. After the T computed, after the T computed is available, then you have to get the T from a T distribution table. Okay, so let's take this one in here. Oh, okay, I'll go direct here. There are two resistors. Electrical engineers comparing the average resistance of two different brands of resistors. Brand X is one of the resistors in that is to be compared, and brand Y is the other. Okay, so hello, Kit. Hello, Mr. Mangada. You have Eda, right? I am now live in YouTube. Okay, I cannot wait for tomorrow anymore because I want to sleep and then finish all the work because it's the only video that I did not finish. Yeah, for final exam. So I just need like 20 to 30 minutes, then I can sleep properly. So there will be no mental baggage anymore. Okay. So go to my YouTube channel, Wonderful Mammy Debs, in the live stream, and you can see this one. You can just say present mom or hi mom in YouTube. Okay. Right. So we've got two groups here, brand X and brand Y, to determine if there is a significant difference in their average resistance. So these are resistors. Okay. So you have to compare if there's a significant difference. And it says here both brands claim to have a resistance of 100 ohms. So you can make first you have to make your null hypothesis that both are the same in resistance 100 ohms, and then your alternative will be they are different. Okay, the engineer randomly selects 20 resistors from each brand, so it means if it's 20 from each brand, then your n for A will be 20 and n for B will be 20 as well, because it says in 20 resistors in each brand and measures their resistance. The data collected is as follows. So brand X has got a mean sample resistance of 99.5 ohms. How did they do that? The 20 samples, they're going to get the resistance for each of them, and then they have to divide by 20. You have to add all the resistances, and then divide by 20. Then you have a sample mean resistance value, which is 99.9. And then the sample standard deviation, there is a formula for standard deviation, and then you have to get the sample standard deviation based from that formula, but it's now given, so don't worry about it. And it's zero point 0.8 for brand A. So that will be your SA, right? So SA is zero point 0.8 ohms. Okay, it's not seen anymore. I just have written ohms in here if you have seen it. Okay. And then SB, I'll better remove that one and put the ohms in here. And then the standard deviation for B would be zero point 0.7. That is brand Y, I mean, and 100.2 ohms for the um, sample mean. This is zero point 0.7 ohm. There you go. Now, use, it says here, there is an advice that you're going to use two-tailed test, whether there is significant difference between the resistances of the two brands at zero point 0.1 significance level. If the significance level is not given, then you have to use the common one, which is 95% confidence level, um, or alpha of 0.05. But because the significance level is given to be 0.01 and the confidence level of this is 99.99, almost perfect, then you have to get the t test distribution value, the critical value, from the table at zero point zero 0.01. We're going to do that. Okay, so now what we will do is to substitute the values in the equation, but let's read this one. In your exam, you're going to formulate your null hypothesis, okay? Null hypothesis, HO. And the null hypothesis in here is there's no significant difference in the average resistance of brand X and brand Y. And in the alternative, which is HA, the one we're using, I apologize for the other notation that has been used here, but it's okay, it's the same. HA, H1, or whatever. Then for as long as that is the alternative, then it is acceptable. There is a significant, here is there is a significant, here is there's no significant, okay, difference in the average resistance of brand X and brand Y. Since we're using equals and not equal in here, then we will be using a two-tailed test. Even if the statement did not say that it's two-tailed, you can see from how it was stated that the mean resistance of X is equal to the mean resistance of Y. So that is two-tailed test. That's an indicator. Okay, so these are the given. Okay, and now the formula. So the formula is, on the numerator, it's the mean of the first one minus the mean of the second, and then square root of the quotient of the square of the standard deviation of that brand, the sample, over the the sample size, and you have to add it to the same standard square deviation of the other group divided by their number as well. Okay, so having said that, let's substitute. The x bar of A is 99.5. The x bar of B, or the mean of B, sample size, is 100.2. And then 0 0.8 will be the standard deviation of A. You square that, divided by the number of sample size, and you're going to add it to the standard deviation of the second group. You square it and divide it by the sample size. Now, the work had been a bit, they made the work easier, I would say, because they have the same n of x is equal to n of y in here, which is 20. Yeah, it says there that the engineer who wants to test the resistance of these two groups or these two brands took 20 from the first brand, brand A, and then took 20 from the other brand, 20 again. So you will expect that the denominator of the quotient will be the same. Okay, calculating T, you will get a value of, okay, because here they are all step by step, like numerator first before the denominator, but you can do that one, um, you can do that straight to your calculator. Okay, now from the calculation you have 2.9 negative 2.94. Let's see if we can get that value. Let's pull out our emulator here and see how I'm going to do it directly from the calculator. Okay, so let's start from a fraction and then open bracket. You just have to type as how it's being shown in the formula, 100.2, and then close. You go to the denominator, and then you need a square root here. And in the square root, you need a fraction. So 0.8 square root, and then you go down, that will be 20. You go to the right, you put the plus sign, and then you put a fraction again. Look at the square root. The line up there, this one, this line here. Yeah, hang on, let me just, this line here expands. There are those students who are not sensitive. You have to look on that. If it doesn't expand, it means that you're already outside the square root and it will not be effective. It will give you a wrong answer. So here is a 0.7 square. Yeah, and then you go down, that will be 20. Okay, so after that, you just press equals and you get negative 2.944. Did we not get the same? Where is it? 0, sorry, negative 2.944, right? For me, it's three decimal places. That's fine. Okay, now what happens is after knowing the t computed is negative 2.94. In your exam, you are given, I repeat, in your exam, you are given the t distribution values. So this is exactly what you will see in your exam. It's on page 5, actually. Now, here are the t distribution values for degrees of freedom from 25 to 30, along with various confidence levels. Alpha. Okay, so you have the alpha here 0.1, you have alpha 0.05, 0.025, 0.1. This is what we're going to use um, in this problem. Now, what is this degrees of freedom? For two groups, it will be the n of uh, the n of b minus the n of a minus 2. Let me just, or plus, let me just um, see the n minus 2. Okay, so it's na plus nb. Let me just correct that one. So it's na NB plus. I'm thinking of another formula. So NF will be NA plus NB minus 2. What is NA? It's 20, right? 20 plus NB is 20 minus 2. That's 40 minus 2. That will be 38 DF. Oh gosh, I don't have 38 in here. Okay. So it means that the question you're going to do in your exam um, is only, you must get a DF between 25 to 30. Okay, we're going to use a, hang on. What I'm going to do is to research from the internet meantime, okay? Let me show you how I'm going to do it. Here, and I'll go here. So I hope you can see me. T distribution. Of course, you cannot do this in your exam. T distribution table of critical values two-tailed. Okay, let me just click that one and let's see. Oh, here you go. So let's pick from here. Where are your values? Here. Okay, so when the DF is 38. Oh, 38 is not here. Look. It's only from 30. It's 40 here. I need 38. Where's 38? Let's see. I think it's there. Oh, it doesn't say it. So we have to go back and then look for another. Let's see this one. It must have 38 somewhere. No, it doesn't have 38. Okay, so we may interpolate, yeah? How is interpolation? But anyway, let's search for 38 meantime. If 38 doesn't come out, then we will do interpolation. What is the value of T critical when DF is 38? Okay, here, let's see. 38, are you there? Okay, there you go. We have it here. All right, so we go to 0.01, so it will be 1, look, 1, 2, 3, 4. Okay, on the fourth column, 38, 1, 2, 3, 4, fourth column, 2.429. Did you see that? 2.429 here. This is 2.429. That is a 38 DF, 2.429. Okay, let's go back there. 2.429. So you have a T table, tabular, T table 2. Oh, look at that memory. This is a two-tailed or what? Upper critical values of this is did not say. There should be a plus and minus, to be honest. Okay, hang on. I have to put there. What is the background? The for a two-tailed test. Okay, we need that. We must not just. Oh, there you go. The critical t value for a two-tailed test with 38 degrees of freedom is 1.689 for a two-tailed test with 38 degrees of freedom. 1.689. So let's go back there. 1.689 negative 1.689. Oh, there. So when you're going to draw your T diagram, because it's what T diagram? Your normal distribution curve, I should say. Um, Negative is here, negative 1.689. Positive is here, positive 1.689. Let me just rub that off. Okay, here is the rejection region. This is the R. This is the R. And our value is, what did I get for T? My T is negative 2.944. So negative 2.944 is over here. There you go. Negative 2.944. What does it mean? You are in the rejection area. Okay, therefore, reject HO here. What is our HO? Our HO says that the two resistors has got the same resistance. So there's no significant difference in the average resistance of brand X and brand B. So you have to reject it. What does it mean reject? You have to accept your null hypothesis, accept the alternative hypothesis. So what does it mean? That they are not the same. Okay, they claim that there's no difference, but uh, for a statistical analysis, then there is, because from the conclusion, then the null hypothesis had been rejected. So you have to accept your alternative hypothesis. That's what it means. Okay, let's go to the decision. There is sufficient evidence at the 0.01 level significance to conclude that the average resistance of brand X and brand B is significantly different. Significantly different. So it means that you have to accept the alternative. Because in the null hypothesis, it says there that there's no significant difference, such that we said that the mu of x is equal to the mu of y. However, this was rejected, right? It was rejected. This one is cross. It was rejected because the alternative hypothesis says there is significant difference. So accept HA. There is significant difference. It means that the resistances of these two, the resistance of X is not equal to the resistance of B. So no significant difference. It means they are the same. Okay, they are the same, but it says that mu X is not the same as mu Y. Okay, so there is sufficient evidence at alpha equal to 0.01 significance level to conclude that the average resistance of the two bronze is significantly different. Okay, so that's all what I want to tell you from the T test computation down to the conclusion. All right, and this is how you're going to conclude exactly similar or exactly the same like how the conclusion had been stated in this problem. Okay, so um where is my StreamYard now? Okay, where is it? Stop presenting. Did I present my screen though? I might be talking here, but there's no presentation there. That will be bizarre, isn't it? Hang on, I will remove this one first so you can see me. Okay, there you go. How is it? Did you understand? Um, okay. I hope I had shared the screen perfectly. Otherwise, or I didn't. If I did not, then that will be a big problem. I have to go through it again. All right, let me see. I might have been talking for 30 minutes already, but there is there's no screen. Let me see. If there is, then hallelujah. Otherwise, I will be in trouble. I have to sleep past. Okay, let's see. Okay, let's skip that one. I just want to see it. Oh, perfect. Okay, it's perfect. It's perfect. Okay, then. So I'm going to end the stream now. Very good. Bye. Have a nice day or good night, everybody.